We're going to talk today about conversion models, which is a take on click models to build really good learning training data. My name is Doug Turnbull. I am the CTO of OpenSource Connections, where we are the consulting firm that works ourselves out of a job because we empower your team to get better and more skilled. And we're hiring right now because a lot of teams need empowering. So I guess we're also working ourselves into more jobs somehow. So we're definitely eager for folks to consult with us. And currently, I'm really proud to be working with a fantastic team at LexisNexis. We have several people from OpenSource Connections. Actually, raise your hand if you're from OpenSource Connections, if you're interested in jobs or have questions about anything I talk about. Bertrand specifically has all the answers. So, and raise your hand if you're from LexisNexis. So 2 really good teams, both hiring. Currently, LexisNexis moving to solar, and they're going to be doing more and more contributions to solar in the community, and it's a really good chance to get in on the ground floor on that stuff. So, and if you're interested more, Dennis Cheney gave a talk yesterday about what the project is. So, we're going to talk about 3 things. We're going to talk about what holds organizations back from AI-powered search. We're going to talk about click models as a potential solution, see if they fit to our search problems. And we're going to play with some ideas and some thoughts I have, you might say some hypotheses on how we might adapt click models to the rest of us, right? Festivus for the rest of us. So I'm really excited about Trey's book, but the question I have is what holds us back from this? Because there's a lot of ambition to be AI-powered and machine learning driven. But how many people have some issues or challenges getting machine learning into production? Lots of people, right? Yeah, me too. And I'm going to talk about one of the major pain points and reasons that this is hard. And it's sort of like, my colleague Liz Halbert likes to say, you got to eat your vegetables. And this is one of the search things where you got to eat your vegetables. If you don't eat your vegetables, you're just going to get sick and things aren't going to work out well with that big, meaty machine learning steak, right? And this is really how machine learning search projects fail, right? We got our garbage in training face, jerk face model, and that's basically what happens with our A/B tests. So this is like version 1 of every learning to rank model I think that I've encountered. And indeed, it's a major theme in our community is you get talks. These are different talks at various conferences. Agnes Van Bell gave a fantastic talk entirely about this problem at TextKernel, just struggling with better rankings and judgments and training data. Get Your Guide gave a fantastic talk. It's just at the Mises conference, I think 2 years ago, just talking about how they were just constantly trying to refine their training data. Haystack Shopping 24 gave a really good talk at Haystack EU, Learning to Rank. 4 iterations of learning to rank consistently below the manual relevance tuning threshold, all because of challenges with training data, right? So this is a chronic problem, and we're going to talk about first why this is so hard. So how many people use judgment lists to measure search? That's good. That's like 90% better than 2 years ago. So a judgment list, for those of you who don't know, you sometimes hear the term golden set, you sometimes hear the term ground truth, but it's this idea in abstract search parlance that we have you have these keywords. In this case, we have Rambo and Rocky are 2 search keywords. We have a document ID that's associated with those, and we grade how relevant a document is for that query. So here we're on a scale of 0 to 4. And the scale is arbitrary. You can choose a lot of different scales. In Rambo, the movie is obviously most relevant for Rambo. Rambo 3 is pretty relevant. And First Daughter gets a grade of 0. It's an F. It fails. It shouldn't count as relevant. If that gets towards the top of our results, we're in trouble. We use this to measure how good search is. It doesn't matter if our solution is machine learning based or someone who picks up the phone and ranks a bunch of results for you based on what they're feeling at the minute. We can measure how good search is, and there's a bunch of statistics that I really encourage you guys to check out, like NDCG and DCG and ERR, that basically take in a judgment list for a query, spit out a number that says, how good is that query relative to the judgment list. So we have our search solution, and if first daughter was towards the top of that, well, we would expect Rambo's NDCG or ERR to be pretty terrible. And there's a pretty strong bias towards making sure the top results are good in these statistics, and no one cares if the 12th and 13th result got swapped. So there's a lot of thinking and math behind that uses judgment lists. But most importantly for our purposes, we care about this for learning to rank training data. So this is also the basis for how any model is going to learn a better ranking for our different queries. So, of course, there's many ways of getting these judgments. There's manual judgments is one way. So this is a tool called Cupid that OpenSource Connections has developed, and it's open source now. And in this case, we have the query Rocky, and a judge is grading Rocky Horror Picture Show. And for some reason, this time we have a 0 to 3 scale, and they're giving this a 2. So reasonably, maybe on the above 50% relevant. Does anyone think that's really relevant to Rocky? Maybe? Okay, Peter does. That's good. Thank you, Peter. And of course, the problem with any of this stuff is, yeah, well, that's just like your opinion, man. There's a really good talk, by the way, by LexisNexis on doing really robust human relevance testing that I definitely encourage you guys to check out, because it's not all for naught. But for our purposes, usually not enough data to do learning to rank training. What we care about is implicit data. And by implicit data, we mean tracking how users are interacting with the search results. And here we have a search for Stuck on Mars. We have Santa Claus Conquers the Martian and Robinson Crusoe on Mars. And maybe people are clicking on Robinson Crusoe for Mars more, it's more relevant. Maybe there's less opinion in this because we're actually tracking real users and what they're actually doing, what they seem to care about, right? That seems reasonable. And you start to ask yourself, okay, well, if I have a lot of session data, how do I turn that data into something that expresses an ideal ranking for this query? We have our clickstream, and I've seen this algorithm several times and come up independently, so it must be right. Maybe if the movie got purchased, we give that movie a grade of 4. If it was clicked and there was a dwell, like there seems to be some interest, it gets a grade of 3. If it's clicked on, it gets a grade of 2. If it's shown, but it's not clicked, maybe a grade of 1, or maybe a 0, depending on our scale. How many people think this is a good approach? Okay, so some people, yeah. How many people think it's a bad approach? How many people don't feel like they have enough to form an opinion yet? That's okay. There are no wrong answers. The main problem, though, the fundamental issue with implicit data, and this is the challenge that all search teams struggle with and beat their head against the wall constantly, and there's no easy solution for, is this idea of self-reinforcing bad search. So we have our search engine, it's showing the user's results. Users only interact with what the search engine shows them. This one weird movie, Santa Claus Conquers Martians, is apparently the most relevant because it's clicked on a lot. And guess what? Our machine learning model learns that, hey, this ranking, your search engine right now is fantastic, and we're just going to keep doing that. That's pretty fantastic. Of course, then we deploy it to our A/B test, and it just tanks, right? And there's 2 biases that come up a lot. There's position bias, which is just the sense that users are going to click on that first result much more than they're going to click on the second result. Just because people scan down the results, they tend to notice the first thing. They might not, even if it's on the page, they might not even notice like the 7th thing down the list. Things are right in front of me all the time, and I don't notice them. And then this idea of presentation bias. So The Martian is a movie about being stuck on Mars. It's not shown in the search results listing. We will never detect that The Martian is a relevant movie for this query stuck on Mars if it's never shown to users? So search teams take out all kinds of tricks out of the bag to get around this. They do interleaving, they do all kinds of stuff to try to give people a chance to click on these things. We're going to talk a little bit about overcoming this problem, some ideas on this, but it's never a fully solved problem. So in addition to trying to overcome that, there's a tremendous amount of domain-specific considerations that come into play when you're building this training data and deciding what a good result is and what a bad result is from your clickstream. So obviously the UI layout has a huge impact on this. If you're, a lot of e-commerce sites are grids now, and I just showed you a bunch of statistics like NDCG that think in things in terms of a listing. Is that a good way to measure a grid of results? What about new and different UI paradigms like chatbots and that sort of thing that show people a ranking? And what happens when we do our UI redesign and all of a sudden our snippeting is different? How does that impact how people are interacting with the search results? What are your users' goals? So it's not necessarily, even in a case where there's a clear conversion, Amazon is really powerful, not just because they make the checkout process easy, but they also are the place you go to look for reviews when you are in the other stores, right? And they've optimized not just for conversions, but they've made you addicted to checking Amazon for reviews and other information, other product information. So it's not just about conversions, even when you're an e-commerce site. Sometimes many domains like legal don't have a clear conversion. There are many reasons that, in legal research, maybe we're just IMDb, people getting information on the movie. There's not a clear oh, yep, they checked out, they like that. They got value out of it. And then more and more, there's this idea of, how many people have heard of the idea of good abandonments? Yeah, a couple people. So good abandonments is the idea that, you see this in Google now, they do really good cards and things. But even if your snippet is pretty good, the user might get the answer from the snippet itself. They might never click on anything because your snippet is that good. It just directly answers that question. So all of these things are complications. And frankly, whatever goes in this bubble is itself a model. It's a set of assumptions. Whatever takes your clickstream and turns into a judgment list, there are good practices, just like there's good practices with human relevance, but every domain is different. E-commerce search is going to be different than job search, is going to be different than news search, is going to be different than than legal search. You go on and on and on. Your intuition is going to fill that bubble, which means, yeah, well, that's just your opinion, man. You can't get away from the qualitative aspect of this, unfortunately. So what are we going to do? It's okay, now we're in the pit of despair. But this means that, when I'm at a client site and we're talking about measuring relevance, clicking and spending greater than 5 seconds on the page indicates a relevant document. There is research to say this correlates with human relevance for some situations, but, is it right in your domain? I think we should oversample clicks farther down the page to compensate for position bias. Carefully inspecting a product is an indication of relevance. All of these are opinions, right? And this is the one that is the kicker, is when I see the 40-minute presentation about the machine learning model, and I get that we improved NDCG by X, and I don't know how they actually measure relevance. Man, that grinds my gears, because I just really want to know, okay, well, what does a judgment mean in your context? What does good mean for your search results to know how you're improving it? And I say that as the overconfident search consultant that has been in that position. These are painful lessons learned, people. The main takeaway, just to take you a little bit out of this pit of despair that we can never know anything and everything is throwaway, is that we can study these models too. These things that we come up with to take a clickstream and come up with an answer on what's relevant and not, those are themselves models that need to be studied just as much as our machine learning models that we're going to deploy that's going to rank results. So in this case, one idea, and there's many ways of doing this, is to put each solution into an A/B test directly. So we have hard-coded ranking 1 and hard-coded ranking 2, and maybe we have our baseline search system. And we're seeing directly, maybe for our head queries, but for a bunch of queries that we actually have this information on, which one of these systems is actually better at corresponding to some A/B tests where we're measuring some important business outcome. There's also systems around consensus with other relevance judgment systems. The best search teams don't just get really good at one system of measuring relevance, they get good at like 3, and they look for consensus. And the other thing that's really important is just like your machine learning models, you're never done here because your UI is going to change, your domain is going to change, language is going to change, how people search is going to change. Search is never ending, and how you come up with the right answer for your the right ranking for your queries is a constantly evolving situation that takes continuous time and measurement. And great search teams have teams dedicated to this, and it's not like a team they spin up for a year and then they go off and they do the great solutioning. It's a team that stays going forever, right? We hope forever, for the whole life of the company. And this is why this is so hard. The UI and the behaviors are changing constantly. Domain and product considerations dominate, and SERP UIs have biases. So, okay, enough ranting. So we're going to pull out of this, and we're going to talk about click models. So click models are an idea that comes from web search. And I want you to think about the specifics of web search when you're going through this. Web search gets a lot of research and a lot of funding. And ask yourselves, are we web search? All these domains are different. The important thing about a click model, in web search, until Google tricked us into putting Google Analytics on everything, we only see the clicks on the search results page. We don't see what happened on DougsCrazyBlog.com to see if people actually seem to like it. So we only see the clicks that's what we can see on the search results page. Those clicks go into a click model. And our click model gives us some really good information on how our click model perceives the relevance of these results. So we have, it's so hot right now. This one is really, really ridiculously good looking. What is this? A search result for Q equals ants? Right? So this is what a click model does, and a click model tries to account for things like position bias when it's doing this. And it's important to differentiate between this idea of attractiveness that goes with perceived relevance. I mean, this is very strongly tied to how users click on results. You clicked on it usually because it looked interesting for the problem you were trying to solve. You didn't fully inspect the document and go through a whole analysis process to see if it's going to solve your problem. So click models really try to get at this idea of attractiveness, which is really the same as perceived relevance. On the other end of the spectrum, we have satisfaction. And there's Homer, he's very satisfied. And satisfaction and actual relevance is also kind of an abstract concept. And it says the document satisfied my information need. What if it only moved it forward and the information need is something that lasts for months, like buying, a car? It kind of moved us forward on my mission a little bit. Some click models attempt S. All click models provide A, so keep that in mind. We'll get into this a little bit. So the world's dumbest click model is just click-through rate, right? So click-through rate, of course, is the number of times something's clicked divided by the impressions. And we can see right off the bat why this is a pretty naive click model. Click-through rate is just going to be completely dominated by position bias. So this is our blog search. And you search for learning to rank, and this first one gets 0.45, and then 0.25, then 0.15. We know just from what we just talked about, this is dominated by position bias. So this is a pretty terrible click model. The world's second simplest click model, but still better, is also called clicks over expected clicks, but it's It's basically a click-through rate divided by the average click-through rate for that position across all queries. So it's kind of a normalized click-through rate. So you can see here that our top result, if position rank 1 here is always clicked on 50% of the time on average across all our queries. And if we divide this query's click-through rate, we might achieve, notice its attractiveness is 0.9. And in this case, instead of going on a scale of 0 to 1, we're going from below 1 is below average and above 1 is above average. And you might imagine that we might assign grades maybe based on some standard deviation above and below that mean. In this case, we notice the second result is the most relevant because it's clicked on above average. Now, one problem with this approach is that it's sort of biased by the overall relevance of your system. So if your system gets more relevant and this query stays the same, every query on here is going to start to become below average, and it's how it's considered relevant, because your denominator is going to go up, right? If your system got more relevant in general, that 0.5 on the upper one, the denominator, is maybe going to start becoming a 0.52 and a 0.53, and so on. So it's somewhat biased by the relevance of your system, which is one reason it's not particularly used. But it's definitely better than click-through rate. So this is where we start getting into slightly harder math, and it looks scarier than it is. All this is saying, gets to be a more probabilistic model. That yellow circle, the click on a document, is what we observe in a session. And we assert that a document is clicked on when it is examined by the user, and I'll talk about what that means in a second, and it's considered to be, the user considers it attractive. Specifically, this position-based model looks at the ranks examined probability across all queries. So we say that rank 1 has a probability, rank 2 has a probability, rank 3. So we have this model across all queries of how each rank's examined probability is. And then each document and query pair has an attractiveness, which is what we're after, right? That's the closest thing we have right now to a judgment. This idea of examine is actually really important to get through your head in click models. Because examine, I said before, imagine, if you see 7 search results in front of you on a web page, well, if 7 search results get rendered on a web page, like the impressions of each of those goes up. But you as a user may not examine all of them. There's a sense that this is trying to model of the likelihood that you actually saw that. And that's actually kind of the underpinning of a lot of these click models, which is a bit different than the click-through rate ones, which are based on impressions. So there's a subtle difference there. And what a click model is trying to learn is both the attractiveness of a document for a query and whether a given rank was examined. And that's a subtle point. And when I walk through this, it might see if this elucidates exactly what that means. Some of these click models, it's like, 2 equations, 2 unknowns, and we solve it and we do some simple averaging and it works out great. Some of them, we use fancier Bayesian statistics to derive a set of assumptions that are going to help us try to converge on the most likely examined probability and attractiveness probability given the clicks that we observe. So we observe this, and we kind of have to find these that maximize the likelihood of the clicks we observe. And that's a pretty trial by error, constantly updating and trying things out process. And it's based around these assumptions. A document was definitely examined if it's clicked. So it's pretty straightforward. If users click it, they examined it. That's an assumption. It's definitely attractive if it's clicked. So both of those are assumptions. And then the other 2 are the subtle ones. So if something was examined and users never click on that position, think about that. So if we notice across all queries that position 2 is always examined in this click model, again, this is one of many click models with its own set of assumptions. But for some reason, when our document is in position 2, it's never clicked on. That probably means that it's not attractive. The document is not attractive. Make sense? On the other hand, if we feel like something is attractive, and frequently attractive things show up in a position, like in that position 2, and they're not clicked on, that probably means that position 2 is not clicked on a lot, or is not examined a lot. And, that's the natural language explanation. And if I was to tell you that, you might even be able to take this natural language explanation and write code around it. But I'm going to take this to the math level, to the terrifying math level. And it's not as terrifying as it looks, because we basically have an update rule where T is an iteration. Every time we update, we converge closer and closer to the ideal attractiveness. We have our clicks. This is just a sum of all the clicks. So C is a 1 or a 0, divided by the number of sessions that query and document appear together. And that's just going to be basically click-through rate, right? But of course, the tricky stuff isn't all the stuff I've hidden from you. And don't cry when I unveil it. But first thing, okay, don't cry, please. You're locked in here, you can't leave. First thing is notice that click is 1 or 0. So you're either in the left case or the right case. And when I write this in code, it is an if statement, not this. In the right case, it's basically the assumption I said before of okay, we're going to update the attractiveness based on the relative to the probability that position is examined. If it's examined a lot, aka 1 minus y sub r, then we're going to probably discount that attractiveness quite a bit. Otherwise, we're going to we're going to improve it. Yeah. So all this is doing is baking, if you were to write this as code, you would just write an if statement. And if you draw out a little table of okay, in this case, you see this output of it was clicked on or not clicked on, examined, not examined. You kind of see how it works. And for completeness, this is more or less the same intuition I said before, but notice on the right when it's not clicked, we're discounting it based on how attractive we thought the document was. We're like, if that thing was attractive, and it was not clicked on, then we're punishing that examined for that rank, right? Otherwise, do the increase it or don't punish it as much. So is everyone good here? We've got this written down. Don't stress out about this too much. The purpose of this talk is not to get too stressed out about understanding this math. The main takeaway is to understand that there is a process for iteratively improving attractiveness, and many of these models have similar update rules that you can deploy and write code for and measure this kind of stuff. So did you ever think there was more to life than being really, really good looking? I do sometimes. So, and this is a shout out to my colleague Liz Haubert, who did a talk on click models at Haystack in April that you guys should go check out. So don't leave the room. It's not so bad. A click model that solves for satisfaction is something called a dynamic Bayesian network. And you can think about it, there's kind of this process of this is exactly the same. Something's going to be clicked on if it was examined and attractive. And they're going to examine the next position if there should be a slash through here, if they were not satisfied with this one. And there is some probability controlling, well, maybe they keep going if they're satisfied. But the most simplified version of this that actually correlates pretty well to the more complicated version is the last thing the users clicked on was the thing that satisfied them. which is, you think that's a pretty naive assumption. But a lot of these things in web search work out in bulk, right? So I wanted to get that out there for completeness. But I think the important thing to remember is that most of us in this room, there probably are somebody, and I'm going to get yelled at, most of us are not building web search. Web search has low visibility, just like I said. We don't see past the search results page. And they have high volume. So they can make a lot of simplifying assumptions that help map just clicks to satisfaction. So a lot of the last thing that was clicked on average, if that happens a lot, so if it's not just the one-off time, but if the last position that a document occurs in, that document is the thing that's clicked on, and that happens 100 times, that feels, out of 100 out of 110 times, that is a strong indication that may have satisfied the user. So most of us are average Joe search teams, which I think a conference like this is really good for. Clicks, conversions, and everything else, we have a lot of visibility past the search results page compared to web search, where click models come from. We have lower volume, though. So a lot of the simplifying assumptions that I just said about that web search can make, we can't make. And I'm going to just say we probably can't trust its estimate of satisfaction for a lot of our queries. We have a lot of tail queries that probably occur a couple times a year. We can't really trust it. So in 8 minutes left, we're going to talk about clicks models for the rest of us. So a click model can be used to overcome search UI biases for us, for the average Joe search teams. And I've seen this in not a lot of data, like the attractiveness and the examine probability for relatively simpler click models that focus on attractiveness does converge with not a ton of data, not a ton of sessions. So what about satisfaction? What about measuring actual relevance? That's the thing we really want to get at, right? That's the juicy nugget of awesomeness that we need to get at. Again, back to our learning to rank models that we're trying to train and measuring relevance and all the good things that come from having high quality judgment data. Can we use our advantage to measure this directly? And again, I said before, all of these models, these are models. They are a set of assumptions. They're just like your machine learning models. They should be tested. We really need to test any way of measuring relevance. So I'm going to give you my perspective on this, but definitely take that with a grain of salt. And this is sort of the beginning of my thinking. You should if you want to take something from this, or you're inspired by it, or you want to take it and build on it, you're absolutely free to do that. I don't have all the answers. I just pretend to at conferences. So we have enough data to determine attractiveness, basically said this. Most of us have some kind of post-click thing that happens after the event, conversions, pseudo-conversions, interactions, indications of interest, not quite goals, but indications the user is happy, like a click plus a dwell. Not everyone has a funnel, so I hesitate to have drawn this funnel. Sometimes I prefer the term path because users take different paths through content. We have clicks. We have some things that should happen right after the click that are still fairly dense. They're shallow and dense, meaning that we should expect them to occur, especially in the context of a relevant document. And most people should get there. Very few people, we should just assume, will make it all the way through, just as a general assumption for what I'm going to present. And this is sort of my perspective. It's like we treat attractiveness in a click model as a starting point. If a user can't even bother to do this really basic thing like click and stay on the page, we probably need to heavily discount that attractiveness if this is something that happens over all the sessions we're looking at. That is a key indication that, okay, we measured attractiveness, we know the click model, that's its strength. But there is a big disconnect between this attractiveness and what happens after the fact. So whatever judgment of actual relevance we know is below attractiveness. And is way below attractiveness. And that's an intuition. Of course, and this probably goes without saying, but this occurs relatively less frequently. If all of these very positive things happen, our attractiveness is confirmed. So I like to think about this as discounting attractiveness based on where people got off the train. If people got off the train on things that everyone is doing, and imagine that there's a set of events here that almost everyone does when something is considered relevant, and there's a set of events that people definitely do. There's kind of a recall precision trade-off here. If people get off at the click plus dwell, then they are probably definitely unhappy with this document. And all the way on the right, we have some very positive indication. And I've made up some numbers here of 0.01, 0.95, and discount. This would be kind of like a multiple, perhaps, on the attractiveness. And I've ranged them from 0 to 1, but they could be some number below 1 to above 1 if that's what you wanted. And if we could look at this over multiple sessions. So we could say, okay, we have our attractiveness, but let's sum all of these discounts that have happened after the page based on the user's interaction with that page. And let's see, where we end up. In this case, we've ended up in a place where, in this situation where everything goes from 0 to 1, what we're going to come out with ranges from 0 to attractiveness. We're going to come out with, we have a purchase, someone immediately returned, and someone stayed on the page and read reviews. We end up with a 0.29. Divide that by the number of sessions. So we've discounted that attractiveness pretty heavily. Compare this to imagine in your head we compare this to something where we have 0.01, 0.01, 0.01, where everyone's just returning to the search results page. That discounted attractiveness is going to be like hitting the floor. That's a key indication we have a disconnect. I think about this in terms of the value users get out of the search results page, out of the detail page. And I think one thing that sort of cuts across domains for me is relevance being tied to value that users are getting. Value is kind of an abstract concept, and value is really hard to measure, honestly. But the one thing we can measure is cost to people in terms of time and money. So we know when someone's taking a long time to read an article or they're invested in whatever this is. And spuriously, people might get really mad and leave. But the deeper and more time people spend on something, that they're investing in that. They're investing their hard-earned time. People only have so much time to look at these things. But when they hit back immediately, they're just not valuing it. So one of my justifications for this is the deeper users get into content, the more they value that. And the shallower they get, if they stay shallow, they don't really value it. So then we discount that heavily. So I've got a couple minutes. I got 1 minute left, and I'm going to show you my 2 minutes. Woohoo! Someone threw a 0 behind that. This is a perspective I've had and started to come out like a framework for thinking about how we might do this. But I do want to take it maybe just the next evolution, which is to think about this from a Bayesian perspective. In my perspective, we have attractiveness, which in Bayesian parlance, we kind of have priors and we have posteriors. Priors are our beliefs beforehand, before more evidence. And attractiveness is kind of like a prior, and the actual relevance is kind of like a posterior. And I've attempted to put that into Bayes' formula and express that. And I don't necessarily, I am not a mathematician, so I sort of just made this up. But it has inspired me to sort of think about this a bit more robustly, where the piece of J on the right is the attractiveness, V being the value the user is getting out of that page, perhaps on average across all queries on the bottom. And then PV conditioned on J is when it's relevant, seen as relevant to a query. And then that sort of inspires me, and I don't think this is entirely great math, but it inspires me on the left to think, well, really what actual relevance is this sort of J, but conditioned on in the context of the value that a user is getting out of that page. And that leads basically to this formula where we have the judgment is the average page value for this query, and page value not being our value as a business, but the value to the user as measured in these discounts that, again, requires a ton of domain thought to think, how would I think about approaching those, times attractiveness that we got it from our click model, divided by the average page value across all queries. And that's going to give us a range of things below 1 and stuff above 1. So we get this like, maybe, I don't know if it's normally distributed, but a nice bell curve around 1 of things that are underperforming relative to their attractiveness and overperforming relative to their attractiveness. And that's really interesting to me. Thank you. So I wasn't sure if that was like the subtle way of playing me off. If we have a page value of average page value of 0.3 here, all I've done here is I've divided, I took the same formula before, but I've divided it by the average page value, and it's given us this, this sort of 0.95, because we're making this 0.7 times this page value relative to that, and it's actually improved the, actually this is a probability, I should say it puts it on a 0 to 1 scale. I said above and below 1. So this is actually indicating it may be more relevant. This is pretty interesting to me. So think about this. And I'm going to leave you, just as my last slide, late in doing this work and really thinking about this, I came across one paper that talks about incorporating post-click behaviors into a click model. And if I had another hour, we would be talking about that. It's definitely also very interesting, and I definitely encourage you to check it out. It's been an interesting read over the last week or two. So I have 3 minutes over, which is not as bad as I thought I would be. Any questions? Yeah. I don't know how much time we have for questions, considering it's the end of the day. Yeah.
Would it make some sense to use different click models for different query intentions?
Yeah, that's a great question. So he asked, does it make sense to use different click models for different query intentions? So an example of that that's very common is the cascading model. Cascading is this idea that users scan and they find what they want and they leave. And that is very much tied to me to known item search. It's like didn't see it. Oh, that was the thing I was looking for, like single known item search. But PBM is fairly general purpose. That's one of the reasons I like it. But it assumes, one downside to that is it assumes in every query, every rank has a comparable probability of being examined. And you're going to have queries that people go through pages of results, and you're going to have queries that people want the first result to be right. So that's a flaw in that model. Yeah?
So when we use the normalized click-through, so that, okay, now we just change the position from 2 to 1 because of, okay, that's more relevant. Now, how are we going to make sure that we are not going to be in the loop? Does that make sense?
You mean you've
now, because the first position, because of the position bias, gets more click. Now the denominator for the same product is now higher, and now second product because having
the denominator is higher, so that one moved up. So you would actually, so the question is, if these things occur in different positions, so what happens is you're actually looking, it's a bit more complicated than that because you kind of sum that up over every session. It's actually probably a sum of clicks relative to the position that they were shown in. So what I show, it's more subtle than what I've shown, probably required 3 or 4 slides, because you're always saying, oh, well, I occurred 10 times in position 1 at this click-through rate, plus 3 times position 2, plus 5 times position 3, and you're looking relative to each position. So it's a bit more subtle than I was talking about. Does that make sense? Yeah. Oh, Andy.
Experience of explicitly asking the user what they thought of the results.
Explicitly asking the user, like of the entire search results page?
Yeah.
Yeah, I think that's a great idea. It gets at a different angle. Yeah.
Imagine it could get in the way of the UX, and people, a certain portion of the audience might want to do that.
Yeah, it depends what you want to measure, because you're measuring lots of different things. You might be measuring like the whole look and feel of the UI. But the more things you have to measure that are sort of independent, well, they're not independent, but are different measures, like types of the more things that you can confirm or deny how your stuff is, if your assumptions are correct, if your model is correct. Yeah.
So you said that Google has, like the pixels, and they use that to their advantage. What features are they using that might help them?
So what is Google doing on our general web page to understand what's more relevant? Well, again, I honestly don't know. Like, so if let's see, and it's going to depend. If you search for, let's say you search for an ambiguous query, where sometimes you get blogs and sometimes you get e-commerce sites, and they have very different success criteria. Like a blog, maybe there's a sense of reading, and an e-commerce site, there's a clear funnel of purchasing maybe, or some events they would look at. They probably look at simpler things. They probably look at like a click plus dwell if they look at anything, just because it's probably more broadly applicable, I would guess. But yeah, eventually, and this is one of the reasons that this stuff is hard and requires a lot of product input, because of the assumptions that go into this become very domain specific, and not even domain specific, product specific. Like grocery search is very different than buying Teslas, which is very different than buying stuff on Amazon. Yeah.
A quick question about, so you introduced two naive click models, and those involve normalizing the number of clicks by impression.
Mm-hmm.
But when we log impressions, we make assumptions as well about whether or not someone's actually looking at that.
Oh, interesting. Yeah.
Right? So I would just wanted to confirm, basically, the final model that you presented, rather than making those assumptions while we're coming up with the numbers of impressions, we're actually including those assumptions in our model. So rather than saying, okay, this user scrolled down and this result appeared, we're just going to say we're modeling the likelihood that they're actually going to get out and look.
Yeah, that's interesting. So in that case, so the question is about the assumptions that go into whether something's an impression, because you're right, because sometimes you return some HTML, it only is an impression traditionally when it's in the viewport, which is different than examines, which is an even more specific definition of something's in a giant, if I was browsing the web on there and like, I don't know, some ridiculous high resolution, I might see 300 search results. They might get in the viewport, but I'm only going to examine like 3. So I think I'm getting kicked out. So yeah, Keynote. Okay, so come find me or go to the Keynote. Thank you.